Okay, so we're going to talk about factoring polynomials. That's why we did the long division activity in class, because we're going to use long division to factor. Um, and so this first page, you can look over it if you want. This is just about factoring quadratics using the box and diamond method. We've practiced that already, but if you want some extra work with it, that might be a good resource. On the second page, these are some factoring shortcuts. I want everybody to just look through this. And we'll talk about them as we kind of go through this unit, but these are going to be really helpful to factor more quickly than the way I'm going to show you, which can be a little tedious. So for starters, we're going to just go over the definition. A polynomial is the sum of any number of terms. So what this means is this is like 4x cubed plus 3x squared plus 2. Remember, a term can be a constant like 2. It can be a variable like x, or it can be a constant times a variable like 4x cubed, 3x squared, 2. So these are three separate terms that we're adding together. So that is what a polynomial is. So now we're going to talk about how to factor them. And to do that, we're going to use two theorems. The first one's called the rational root theorem. The second one's called the remainder theorem. And these are basically going to tell us what the roots are so that we know what to divide these by evenly. So the rational root theorem says any rational roots of a polynomial are some combination of the factors of the constant term divided by the leading coefficient. So rational roots, rational numbers are just numbers that can be written as fractions. So those are really what we're going to be working with when we do these. Use this theorem. There are other ways to find other roots, like square root of 12 or something you'll see on the previous page. But for this specific theorem and way of doing this, it's only going to be rational numbers. And then what does it say? Rational roots of a polynomial are some combination of the factors of the constant term. So the constant term is 6. It's that 6 at the end. Because there's no x, that means it's constant. X changes, but if there's no x, then it doesn't change. And then factors of the constant term divided by the leading coefficient. Leading coefficient, it's going to be 1, because it's 1 times x cubed. So then we've got a constant term and a leading coefficient, but it says the factors of the constant term. So it's not just the 6. It could also be the factors of 6 are plus or minus, right? It could be negative numbers that are factors of 6, but 6 is the first factor. And then 6 divided by 3 is 2. 6 divided by 1 is 1. So those are the only factors of 6. We can't divide 6 by 4, or we can't divide it by 5. So these are the factors of 6, and plus or minus, right? The negative ones are important too. Can't forget that. Divided by the leading coefficient, which in this case is just 1, which is really nice and tidy, because we can actually get rid of that, so it's not even going to be a fraction anymore, and we can rewrite these as plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. Those are all our possible factors for this polynomial. It's not all of them. This is a cubic function, right? The degree is 3, which means there's only going to be 3 roots at maximum. But we've narrowed that down from all the numbers to 8 possible numbers. So now we're going to use the remainder theorem to figure out which one it is. So the remainder theorem says when a number is plugged into a polynomial, if the result is 0, then the factor that matches it goes into the polynomial. So that means if I plug a number into this polynomial for x and it equals 0, then the factor that I plugged in, that's going to be the factor that matches that number. So if I plug in 5, the factor that matches it is going to be x minus 5. It's not going to be 5 because that's not one of our possible factors. So now we are going to just check some of these numbers. And my general rule of thumb is always check the easiest ones first. So first, let's check negative. So as you can see here, I've plugged in -1 for x in this polynomial, and now I just need to evaluate. Notice that I used parentheses because If you don't, you're going to lose track of your negatives and you're going to make mistakes. So negative 1 cubed is negative 1. 0 times anything is 0. Negative 7 times negative 1, that's plus 7. And then plus 6. So this ends up equaling 12, which does not equal 0. Therefore, negative 1 is not a root. So then let's try positive 1. I always check negative 1 and positive 1 first because they're the easiest ones to do the math with. And that also means I'll probably choose those types of numbers on quizzes and stuff because I don't want you to spend a lot of time multiplying a bunch of 6's out. So I've plugged in 1, and that gives me 1 plus 0 minus 7 plus 6. And that actually adds up to 0. 0 equals 0. Therefore, 1 is my root. Therefore, 1 is a root. So my factor is going to be x minus 1 is a factor. And that is according to the remainder theorem. So now we're going to do some long division to factor it. Okay, so x goes into x cubed how many times? X squared times. X squared times x is x cubed. X squared times negative 1 is negative x squared. Parentheses here and subtract. X cubed minus x cubed is 0. 0, x squared is just 0 minus negative x squared. That's plus x squared. And then we're going to bring down the minus 7x. All right, now how many times does x minus 1 go into x squared? That's x. So plus x. X times x minus 1 is x squared minus x. Subtract that. X squared minus x squared is 0. And then negative 7x minus negative x, that's plus x. So that equals plus 8x. And then we'll bring down our 6. Plus 6. X minus 1 goes into 8x 8 times. Or x goes into 8x 8 times. 8 times x minus 1 is 8x. Sorry about that. I made a mistake here. Negative 7x plus x is negative 6x. So this is negative 7x plus x. So then we're at negative 6x. And then we bring down this 6. So x goes into negative 6x. Negative 6 times. Negative 6 times x is negative 6x plus 6, which is, that means those are equal. You subtract one from the other, and you get 0. So 0 remainder means that it goes into it evenly. Therefore, it works. So now we can rewrite this original function as x cubed plus 0x squared minus 7x plus 6 equals x minus 1 times x squared plus x minus 6. So now we've factored it down to a quadratic and a monomial. So now it's a lot easier to work with. Now we can just do what we normally do to factor a quadratic and figure out the answers to this. So I want to factor x squared plus x minus 6. You can do box and diamond. I'm going to skip over that just because I know what it is. I can just look at it and say, well, this is equal to x minus 1 times x plus 3 times x minus 2. And you all know how to do that, so I'm not going to spend a whole lot of time on that. So the factored form is this right here. And then the roots would be, there's two ways to write this that I'm going to want to see on a quiz. It's going to be x equals 1, negative 3, and 2. Remember, it's just the opposites of these numbers. Or you can write it as 1, 0, negative 3, 0, and 2, 0. And that's it. We'll go over grouping later, but for now I just wanted you to get the rational root theorem and the remainder theorem.